Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Numbered Rooms Intro, and it's by Donatello86. And here are the rules. We have normal Sudoku rules apply, which means place a single digit from 1 through 9 in every cell in the grid such that there are no repeats in any row, column, or box. We have numbered rooms, where a clue outside the grid indicates the digit which has to be placed in the nth cell in the corresponding direction, where n is the digit placed in the first cell in that direction. For example, if row 2, column 1, is a 7, then 2, which is the digit outside of the grid, outside of this specific row in this direction, must be placed in row 2, column 7. So this would have to be a 2 if this were 7, because this is saying 2 has to be in the 7th spot, 7th cell in this direction. Yeah, and that's an example of how numbered rooms work. We have, if, for example, let's do another example. Say this was a 5. That would say 2 has to be in the 5th position in this row. So 2 would have to be here if that were the case. That leads to some interesting, deductions you can make, but we'll get to that when we solve it. We also have cells separated by a white dot contain consecutive digits, and cells separated by a black dot contain digits in a 2-to-1 ratio. So these are typical Kropke dots. So if, for example, this were a 6, this would have to be 5 or 7 to make sure that these digits are consecutive. If this were, say, a 4, this would have to be 2 or 8 to make sure that these digits are in a 1-to-2 ratio between them. And those are all the rules. As the title says, this is a numbered rooms introduction. So this is actually just sort of giving you an idea of how numbered rooms work. It's a fairly common rule set. Not necessarily the most common, but it's, there's a decent amount of puzzles that have this rule set. So it's good to know about this. Anyways, if you want to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. Okay, so anytime you have numbered rooms clues, well, first of all, anytime you have a numbered rooms clue, which does not have a 1 or a 9, actually does not have a 1 on the outside clue, you know that the first digit cannot be 1. Because if the digit is a 1, it's saying that whatever digit is outside the grid must have that digit in the first spot, right? If it is a 1. But obviously, if it's 1 already, it can't be that other digit unless it is 1 specifically. So none of these can be 1, this can't be 1, and these can't be 1, right? So where is the 1 in row 1? It has to be either here or here. And that's an example. That's always going to be the case for numbered rooms clues. Another deduction you can make is anytime you have 3 of the same numbered rooms clues in the same that are in the same box, I guess you could say, right? So specifically, I'm looking at things like this. These 3s all are in, well, they're across the same. How do you describe it? they cover the same boxes, right? So these all cover these 3 boxes. Well, this is guaranteeing that 3 has to be in all these boxes here, right? Because we have 3 threes that we have to account for. There's a 3 in one of these boxes. There's a 3 in one of these boxes. Well, apologies, I'll get the boxes right. There's a 3 in one of these boxes, and there's a 3 in one of these boxes. That accounts for all 3 boxes. Therefore, you know one of these digits. So one of these digits here must be 1, 2, or 3 to account for the 3 in this box. The other 2 have to be respectively 4, 5, or 6 to account for the 3 in this box, or in 7, 8, or 9 to account for the 3 in this box. So one of these is 1, 2, or 3. The other one is 4, 5, and 6, and then another one is 7, 8, and 9. So you have one from each of those sets. 1, 2, 3, 4, 5, 6, and 7, 8, and 9. And that's anytime you have 3 of the same numbered rooms clues in the same boxes, right? That would not apply here, for example, right? You could have a 3 here and then a 3 here, and that would be valid. But if you have a 3 here, you can't have a 3 here or a 3 here. So this would have to be not 1, 2, or 3. If you had a 3 here, you couldn't have a 3 here or 3 here. So this couldn't be 4, 5, or 6 if this were 4, 5, or 6. And then similarly, this would have to be... if there's a 3 here, there couldn't be a 3 here or a 3 here. So these could not be 7, 8, or 9 if that were the case, if this was 7, 8, and 9. So we know that for both of these 2's here and these 3's here, well, these digits are consecutive. But we know, again, you have to have one digit from 1, 2, 3, one digit from 4, 5, 6, and one digit from 7, 8, or 9 here. So what digits are consecutive? Only 4 and 6 can be consecutive with 3 and 7. So this must be 3, 7, or 4, 6. What about these? Again, you have 3 digits here, since there's these two number room clues are all from column 7 to column 9, which only takes into account 3 boxes here. So all the 2's must be 1 from 7, 8, 9, 1 from 4, 5, 6, and 1 from 1, 2, or 3. And what are the digits that can be consecutive from there? It's only 3, 4, and 6, 7, right? Because they have to be different sets. So it's either 1, 2, 3, 4, 5, 6, or 7, 8, 9. And the only way you're consecutive is 3, 4, and 6, 7 from those sets. Therefore, we have a 3, 4, 6, 7 quadruple in row 1, which eliminates 3, 4, 6, and 7 in the rest of the row. Therefore, we know the rest of the digits in row 1 are 1, 2, 5, 8, 9. But 1 obviously can't be either of these. We also cannot have a 5 in either of these, because if 5 were here or 5 were here, the problem is you would have to have a 4 or a 6 here to be consecutive. And you'd have 2 from the set 4, 5, and 6 in this cell. So therefore, say this was 5. If this was 5, that's saying 3 has to be here, but one of these is 4 or 6 to be with a 3 or 7 consecutive. And obviously, if 4 were here, if this were either of these were 4, 3 would have to be here, and we'd have a duplicate. If it was 6, there would have to be a 3 here, and there would be a duplicate. So neither of these are allowed. So this cannot be 5, and this can't be 5. We know, therefore, one of these is a 5. Similarly, here we have 3 digits, and because these are 3 digits, one from 1, 2, 3, one from 4, 5, 6, and one from 7, 8, 9. Same here. These have digits, one from 1, 2, 3, one from 4, 5, 6, and one from 7, 8, 9. These also have to have 3 digits, one from 1, 2, 3, one from 4, 5, 6, and one from 7, 8, 9. It's just how it works out by just set theory, essentially. So these cannot be 2 here. This has to be an 8 and 9 here. And one of these must be 8 or 9. Well, can the 9 can this actually be a 9 here? And the answer is no. If this is 9, that's saying 9 has to be in the 9th position, but we already have a 9 here, which is in the 1st position. So this cannot be 9. Can't be 1, obviously. Can it be 8? If it were 8, 9 would be in the 8th spot, but 9 can't be double another digit because it's double 4.5, which is not a digit. And you can't double 9 to get another digit because double of 9 is 18. So this cannot be 8. This has to be a 5. So 9 is in the 5th spot here. So this is 9. Neither of these can be 5. Therefore, 1 is either first or it's in the 8th or 9th position. We're not sure which. So these are still open to possibilities. Okay. Another thing about numbered rooms is the digit cannot be the same digit, the first digit, shall we say, the n digit, essentially, which is the first digit you see, cannot be the same as the digit outside of that is the numbered room clues. And the logic there is obvious. Say this was a 2, right? If this is 2, that would say 2 is in the 2nd position, but we already have 2 in the 1st position, and that's a contradiction. So we know this cannot be 2. Where is the 2 in box, row 1? It has to be here. So this is 2, which means 3 has to be in the 2nd position. So this is 3, which means 3 cannot be here. Therefore, this can't be 4 consecutive with it. This must be a 6-7 pair. 6-7 eliminates 6 and 7 in the rest of the row. Therefore, this is a 3-4 pair, saying 2 has to be either in 2, here, or here. 3 has to be one of these two. 3 cannot be the first digit, again, in a number. This can't be the same digit as the digit outside in the number rooms clue. So this cannot be 3 here. Therefore, where is the 3 in column 1? It can't be in 6, it must be in 7. So this is 7, this is 6, which forces 3 to be here. This can't be 3 anymore. This 6 says 3 has to be in the 6th spot, so 3 is here. 3 is in a 1-to-2 ratio only with 6, so this is 6. Where is the 3 looking this way? It's 2. And where is the 3 looking this way? It's 8. And so that's another thing that you can figure out. 2 has to be either an 8 or 9 here, right? It's in this one of these two spots because it's either 3rd or 4th here. This is 8th or 9th, so 2 has to be one of those two. 2 cannot be here. 2 can't be here. 2 has to, 2 can't be here because of the 2 in the box. So it's 4, 5, or 6 here. Which means this has to be 4, 5, or 6 because it matches this. And one thing we know, okay, so the 2 cannot be here. If 2 were here, both this would have to be 5 and this would have to be 5, and we'd have 2 5s in the same row, which is not allowed. So 2 has to be one of these two digits, which means this cannot be 5 and this cannot be 5. So anytime you have two numbered rooms clues, which are the same numbered room, they cannot be 5 essentially, and they have to add up to 10 essentially. So that's more of the uniqueness, right? That's why we know this is 2 and 8 adding up to 10. This has to be 8 to add up to 10 to make sure that this matches that 3. So this is 8. This 6 eliminates 6 here, so this is 4, which means 2 has to be in the 4th spot, so this is 2. This can't be 2 here. That means from this direction, 2 is in the 6th spot going that way, so this is 6. 9. Let's see, what else do we have? 8 is here. The remaining digits so this is 6, that's fine. The remaining digits in this upper left-hand box are 1, 5, 8, and 9. Okay. These two digits must add up to 10 because of the reasoning that we said, right? Anytime you have two numbered rooms clue looking from both directions and they're the same number, obviously one of them looks one way and the other one looks the other way. Well, you'll always have 1 or 9, 2 and 8, 3 and 7, 4 and 6, and that's why it adds up to 10. So this must be 1, 9 adding up together to add up to 10, or 2, 8. Well, it cannot be 2 and 8, so this must be a 1, 9 pair because you can't have 2 in the column. So this is 1 or 9, this is 1 or 9. And they both could be 1 again, because 1 is the only digit that can be a numbered room clue outside, which could have a 1 in that spot. The remaining digits in column 4 are 3 through 8. This can't be 3 or 6. This can't be 3. This can't be 5 or 7 because of they're next to a black crop key dot. This can't be 8. So what digits can this be consecutive with? 4 can be consecutive with 3 or 5. 5 can be consecutive with 4 or 6. And 7 can be consecutive with 6 or 8. Okay. Either this is 3 or 6, or it's 2, 4, or 8. Well, we know there's a 2 in one of these two cells, right? Because this is a 4 indexing, which says that 2 has to be in the 4th spot. So 2 can never be here. Where is the 2 in row 5? Can't be here because of the 2 in the box. Can't be here because we know one of these is a 2. So this must be a 2 here. This 8 eliminates 8 from being there. This must be 8 and 9. This 9, this end digit for the 9, it could be 7, 8, or 9. It could be 2, technically. Oh, well, say this was a 2. If this was 2, that's saying that 9 has to be in the second spot that it sees. So this would be 9, which would force this to be 8, but then 8 going this direction is not a 2, it's a 9. So this can never be 2 here, which means this has to be 8, which forces this to be a 2. This can't be 8 anymore. The 9 cannot be in the 9th spot. So this is 7. It cannot be 1. It cannot be 3 or 4. It could be 5, and it cannot be 6. So this can't be 8 here. 9 cannot be in the 8th spot going this direction, so this can't be 9. This can't be 2, so this 2 means this has to be the 3rd spot here. So this is 3, this is 4. That means this is 2. 2 has to be in the 2nd spot this way. Well, sorry, 1 has to be in the 2nd spot this way, so this is 1. So 9 has to be either in the 5th spot or the 7th spot, and it can't be in the 5th spot because we have a 9 already in that column. So this must be 7, which makes this a 9. This can't be 9. This is a 1, 5 pair. This can't be 7 or 8. What else do we have? Okay. Now, let's look at column 9. What are the remaining digits in column 9? We have 1, 3, 5, and 9. But this can't be 9 because of the 9 in the row. This is 1, 3, 5, or 9. But this can't be 3 because of that 3. 1 again cannot be here because it's next to a numbered rooms clue, which is not a 1. 4 could be in the 3rd spot, the 5th spot, or the 9th spot. It cannot actually be in the 9th spot because of the 4 there. So it's in the 3rd or the 5th spot. 3 cannot be in 7, 8, or 9 because in this can't be 1 here. We have in column 9 a 3, 5 pair, which eliminates 3 and 5 in the rest of the column. So this is a 1, 9 pair here. Okay. This 3 cannot be here because of the 3 in that box. So it can't be 7, 8, or 9 here. It cannot be 1, obviously. It could be 2, 4, 3, 4, 5, 6. It can't be 3 because it can't be itself. If this 3 has a 3 here, that's saying 3 has to be in the third spot, which it can't be because it's already in the first spot. So this is 2, 4, 5, 6. 3 has to be in the 8th spot, so 3 cannot be here. So 3 cannot be in the 4th spot going this way. We know this cannot be 1 or 9 for the 1, 9 pair in the row. Can't be 8. Can't be 5 or 6 or 3. So what are these possibilities? No 1, could be 2. No 3, could be 4. Could not be 5 or 6, could be 7. So 4 cannot be the 7th digit here. So 4 has to be either in the 2nd spot or the 4th spot, and it can't be the 4th spot. So this must be the 2nd spot, which means 1... Sorry, it's 1 has to be. Oops. So this is 2 or 7, so that's valid. So this cannot be 1 here because it can't be in the 8th spot. So this is 5, which makes this 1, which makes this 7. Okay. 5 cannot be in the first spot. What can this be? 1 can't be here. 1 can't be here. What are the remaining digits in column 1? We have 1, 5, 6, and 9. This can't be 1 because you can't have 1 in the first spot unless it's 1 outside as a clue. This can't be 1 because of the 1 in the row. This can't be 9 because of the 9 in the row. This can't be 5 because that's saying that 5 would have to be in the 5th spot, which it isn't. And it can't be 9 because of the 1, 9 pair in the row. So this must be 6. That's saying that 5 is in the 6th spot going this way. So this is 5. Which means this can't be 5 or 6. This must be then a 2. So it's saying that 3 has to be in the 2nd spot. So this is 3, which means this can't be 3. This is 5, which makes that 3. 2 has to be in the 9th spot looking this way. So this is 9. This cannot be 9. So this is 1, which makes this 9. That's saying not 1 has to be in the 9th spot, which it is. 1 is in the first spot, which it is. This can't be 1 or 9. This is 8. This can't be 5 anymore because of the 5 in the box. This can't be 3 or 5. This can't, well, okay, this can't be 5 or 6. And these can't be 6. Okay. This 9 eliminates 9 here, so this is 1. This is 9. This can't be 3 because of the 3 in the row. Where is the 3? It's one of these two, but that's still pretty broad. Okay, where is the 5 in row 3? Cannot be here because of the 5 in the box, and the rest are filled out, so this is a 5. That leaves us as a 1, 8 pair here, and this can't be 1 because of the 1 in the row, so this is 8, this is 1. That leaves these digits as 7 and 9, and this can't be a 9 because of the 9 in the column, so this is 7, this is 9. That leaves these as a 3, 4, 6 triplets. What are these digits? It has to be 3 and 4. This can't be 3 because of the 3 in the box, so this is 4, which makes this 3. That means none of these could be 3. Where is the 2 in column 5? Cannot be here because of the 2 in the box. Can't be here because of the 2 in the box. Can't be here. So one of these is 2. So it must be within a 1 to 2 ratio with 1 or 4 here. That leaves this digit. Cannot be 3, 5, 7, or 9. So it could be 1, 4, 6, or 8. But it cannot be 6 or 8 because of the 6 and the 8 in the row. So we have a 1, 2, 4 triplet, which eliminates 1, 2, 4 in the rest of column 5. This can't be 4. This is 6. This can't be 4 or 6. This is 8. 8 is only in a 1 to 2 ratio with 4, so this is 4. That means this can't be 4. This is 1. This has to be a 2, 4 pair here, which eliminates 4 in the rest of the box. This also can't be 5 because of the 5 in the box. Therefore, one of these is 1 here. These can't be 6. This can't be 4. Therefore, this must be 3, which makes this 4. None of these can be 4. One of these two digits must be a 5. And 5 can only be consecutive with 4 or 6, but we can't have a 4. So it must be 5 and 6. So this is 6, this is 5. These can't be 6 here. That's a 7, 8 pair. This must be a 1, 6 pair here. That leaves in column 6, the remaining digits are 3 and 7. And this can't be 3 because of the 3 in the row. So this is 7, which makes this 3. In row 6, we have the remaining digits are 4 and 9. And this can't be 4 because of the 4 in the column. So this is 9, this is 4. And this is just all normal Sudoku now. Because... So, the remaining digits in column 8, we have 5, 6, and 7. Well, 5 cannot be either of these, so this must be 5. This must be a 6, 7 pair. That leaves the rest in the lower right-hand box. What is the remaining digit? It must be 8, which must be here. So this is 8, which eliminates 8 here. So this is 7, this is 8. 7 eliminates 7 here, so that's 6 and 7. 6 eliminates 6 here, so it's 1 and 6. Remaining digits in column 7 are 6 and 7. And this can't be 6 because of the 6 in the row. So this is 7, this is 6. Remaining digits of row 7 are 2, 4, and 5. 5 cannot be here. Where can the 5 be in row 7? It has to be here. So this is 5. This is 2 or 4. Remaining digits in row 8 are 1, 2, 4, and 9. Well, this can't be 2 or 9. This can't be 1. Okay. So, the remaining digits in row 4 are 5, 7, and 9. Well, 5 cannot be either of these, so where is the 5? It has to be here. So this is 5, which makes this 1, which makes this 9. So this cannot be 9 here. Therefore, we have a 2, 4, 2, 4 pair in this box, which eliminates 2 and 4 in the rest of the box. Therefore, this must be a 1. This 9 eliminates 9 here, so it's 7 and 9. We have remaining digits. This has to be an 8. The 4 has to be in the 5th spot here. So this is 4, which makes this 2, which makes that 4, which makes that 2. And therefore, this is the 4 here. And that's how you solve it. Yeah, so there's a lot of interesting logic involved with numbered rooms. So it's always kind of fun to do. Anyways, I hope you enjoyed this episode of Learn How to Sudoku. And I'll see you next time on Frank Puzzles. Take care.